Hello, everybody. Welcome to the NVIDIA Omniverse live stream. Very excited to have you here today with us. We've got very special guests, as is typical. But today, you're going to be joining NVIDIA experts for a live stream exploring how digital twins are unlocking new possibilities for the world's industries. We're going to learn how developers are using OpenUSD to build new workflows and applications that power physics-based AI-enabled digital twins for real-time simulation and optimization of products, facilities, and processes. We have a very special guest also from the community. Omniverse Ambassador Michael Wagner is joining us from SyncTwin. Michael, it's so awesome to have you here today.
Thank you for having me. Yeah, great.
So before we get started, I'm going to just present a couple of news announcements that we wanted to share with everybody, and then we'll get started into the topic of the show. The first thing is, if anyone has been watching the live stream regularly, you have not missed some great content from Edge Impulse. Jenny Plunkett in particular has been on the stream, and she will be guiding a webinar on May 14th on leveraging synthetic data for the Edge and utilizing OpenUSD and NVIDIA Omniverse. We're going to post the link for that webinar in the chat. Amelia, our producer, is standing by, and she's going to help with all the links during the course of this live stream. It should be a great webinar, and it's just coming up in several days. We'll also post a LinkedIn post on this, and it should be out. I see Michael Geyer's here, so we're going to bring him in. Mike, I will bring in your camera. Here you go. There he is.
Hey. How's it going?
Hi, Mike.
Hey.
Just in time.
Let's see.
Okay. So everyone, make sure to catch that webinar coming up with Jenny Plunkett. We'll also post the link for that live stream that she did as a little preview if you'd like to see it. It was fantastic, and just a couple months ago. All of our OpenUSD training labs are now available on demand. I'm referring to NVIDIA On Demand, of course. We'll post a link for this in the chat. This is one of the most valuable and free resources you can get from GTC. So experts are guiding you through different workflows, and everything is available without any barrier. So go ahead and check out the link in the chat now, as well as other content from GTC. All in addition to the labs, all the sessions are now available to replay at your convenience. And some of them are worth watching more than once, I should say. And you can watch it at your own pace as well. So feel free to dive into there. We'll post a link in the chat. We had Ian Fisher from Siemens on recently. And we have got a great article on unlocking the future of manufacturing with OpenUSD and Siemens Teamcenter X. This was actually part of GTC recently, and we had this demonstration at the NVIDIA booth. Really fantastic, informative article. We're all big fans of everything Siemens is doing with OpenUSD. So check this out and be inspired. Speaking of inspired, we have the OpenUSD Community Challenge in full effect right now. It's called #OpenUSD Challenge. Basically, it is as it sounds. We would love to see your work leveraging OpenUSD, whether this is the first time you're fooling around with OpenUSD or you've been there since the beginning or any point in between. Just share your work on any kind of social media of choice and use the #OpenUSD Challenge so people could find it, and let us all celebrate together and be inspired by your great work. Okay, now we have a very special panel here with us today. So starting with Michael Wagner, and right next to me from SyncTwin. Michael, thank you. Speaking of GTC, you were a big part of GTC. It was great to hang out there.
Yeah, that's awesome.
Tell us a little bit about, if the people might not be familiar with you and your work. Can you give your background a little bit and then discuss kind of this company you started, SyncTwin?
Yeah, sure. SyncTwin is a spin-off of our main company, Epolog. We're working in the automotive industry to create logistics and production planning software. And with our biggest customer, BMW, we came into contact with NVIDIA and Omniverse, and I said, oh yes, this is exactly what I was looking for the last 20 years. So we jumped right in and created like SyncTwin, which is doing solutions based on Omniverse and OpenUSD. So we're helping basically the small and medium-sized custom enterprises to get into the industrial metaverse as the big OEMs are doing it as well.
Very cool. So we're gonna dive into a lot more of this in the coming hour. So everybody, stay tuned. Feel free to use the chat if you have a question or comment for anyone in the live stream or for NVIDIA in general. Amelia is watching that chat like a hawk. We'll try to be posting links throughout the live stream. Okay, so Michael, we're gonna circle back, and Michael's got a great demo plan. He's gonna show and tell some sync twin workflow in just a few minutes. Next to you is my colleague, Raphael. Raphael with a great screen background there. How you doing, Raphael?
Hi, guys.
Thanks for joining us today. Why don't you give everyone out there some background on kind of what your focus is?
So this is more like, okay, can you see it better now? So I played around with Midjourney, and so this is one of the results, just to share an example of how great content you can create using AI tools like Midjourney.
I want that robot.
I sent it to you.
And so what's your focus on NVIDIA right now?
So I'm part of the Omniverse product management team. So Mike is my boss, so I'm reporting to him, and I'm responsible for all the factory topics right now. So whenever it comes to a digital twin in a factory, no matter if it's manufacturing industry, automotive industry, semiconductors. So I work super close with Sebastian here and some other folks, and try to cover it from a product management perspective.
Awesome. Well, it's great to have your point of view during this live stream. So thanks for joining. All right, let's talk to your boss. We don't need to get into how Raphael's doing lately. We want to talk about how are you doing, Mike? And it was great to see you at GTC. You had a really great interview with Rafi that was posted and shared on LinkedIn recently. He also actually had a great interview with Michael Wagner that was posted. So great to have you join the live stream. You want to, for those who might not be familiar with your role at NVIDIA and your focus, you want to give everyone a little summary?
Yeah. Hey, thanks, Edmar. It's great to be here. Hey, everybody. Good to hang out on the live stream. My name is Mike Geyer. I'm based in Portland, Oregon, and I'm just a guy that's always been fascinated by how stuff works. I was always taking things apart as a kid, pulling apart the DVD players in my parents' garage, and then when I figured out I could get a job finding out how all this stuff is made, I was even happier. And so that's kind of been my whole life is walking through factories and shops like you see in the background of everybody's screen here, and just kind of endlessly curious about all the amazing stuff that goes into building the things that we use in our everyday world. So I'm really thrilled to be part of the NVIDIA team that's working on digital twins. Have learned so much from the folks like Raphael and Sebastian and Michael Wagner. And I'm looking forward to learning a lot from this group here today. So yeah, just really excited for the conversation.
Awesome. Well, thank you. And actually, that video was so great. Well, Amelia, if you can, during the live stream, we can post a link to Mike's and also Michael, both Mike's, their interviews with Rafi, because I think that would be great follow-up viewing for everybody. Okay, last but most certainly not least, the man with the great factory in the background, Sebastian, how are you doing?
I'm doing great. Yeah, thank you, Edmar, for having us. I did one of these, I don't know, maybe a year or two ago when we were talking about some of the AEC workflows and other stuff. But yes, my background is originally in architecture, but really been focused on building out nice tools and platforms for people to create wonderful digital twins, basically bringing everything that's physical to the digital world. My role at NVIDIA is as a product manager, so I work on some of the core technology and platforms that we're putting together for folks to build amazing applications and services on.
Oh, awesome. This is perfect. This is a great panel. So I'm very excited. All right, so let's dig into it. I guess first, we actually have a few nice videos to show off. But maybe before we watch the first video, for anyone just tuning in, we're going to be exploring physics-based digital twins with OpenUSD. Who would like to give us kind of a definition of what digital twins actually are? Because I think that meaning could alter a little bit depending on your background. Who wants to take a stab at that?
I could take a stab at it. I think this is one of the first questions you get asked when you start talking about digital twins. Like, what the heck does that mean? But the way we think about it at NVIDIA, we have a pretty strong opinion that a digital twin is the coupling of a physical and a virtual system, and that in order to truly be a digital twin, the properties of the physical system as it exists in the real world, meat space, if you will, should be replicated exactly in the digital model of it. And they should also be linked and synchronized. So as something moves in the digital realm, it also moves in the physical realm. And the data that comes off that system in the physical realm is passed back and forth. And it doesn't have to be a whole car. It doesn't have to be a whole factory. You could have a digital twin of a single robotics line or a single manufacturing cell. But that's kind of how we think about it. I don't know, Michael or Raphael or Sebastian, you guys want to add any more color?
Also the processes. It's not only the physical devices, but also you can basically have the complete digital twin of your organization and of your processes as well. So I think this is also a nice aspect.
That's a great point. So we do have a few videos to show off. Do you think would it help to kind of also frame this by playing one of those videos, or do you want to start with presenting? I think we have a small deck to show off.
Maybe we can start with a movie first, then the deck, and then the second movie to mix it up a little bit.
I love it. So we got a few. So which case did you want to start looking at first?
I would start with the BMW movie.
Okay, and I see Michael acknowledging there. Michael's got good experience with BMW.
Yeah.
So we'll talk about that in a minute. But let's watch this really fantastic video of BMW.
The world's industries are accelerating digitalization with over $3.4 trillion being invested in the next 3 years. We at BMW strive to be leading edge in automotive digitalization. With NVIDIA Omniverse and AI, we set up new factories faster and produce more efficiently than ever. This results in significant savings for us. It all starts with planning, a complex process in which we need to connect many tools, datasets, and specialists around the world. Traditionally, we are limited since data is managed separately in a variety of systems and tools. Today, we've changed all that. We are developing custom Omniverse applications to connect our existing tools, know-how, and teams all in a unified view. Omniverse is cloud native and cloud agnostic, enabling teams to collaborate across our virtual factories from everywhere. I'm about to join a virtual planning session for Debrecen in Hungary, our new EV factory opening in 2025. Let's jump in.
Milan is joining.
Hello, everyone.
Hi, Milan. Great to see you. We're in the middle of an optimization loop for the body shop. Would you like to see?
Thanks. I'm highly interested. And I'd like to invite a friend.
Sure.
Hey, Milan. Good to see you.
Jensen, welcome to our virtual planning session.
It's great to be here. What are we looking at?
This is our global planning team who are working on a robot cell in Debrecen's digital twin. Matthias, tell us what's happening.
So we've just learned the production concept requires some changes. We are now reconfiguring the layout to add a new robot into the cell.
Okay, but if we add a new robot on the logistics side, we need to move our storage container.
All right, let's get this new robot in.
That's perfect. But let's double check. Can we run the cell? Excellent.
Milan, this is just incredible. Virtual factory integration is essential for every industry. I'm so proud to see what our teams did together. Congratulations.
We are working globally to optimize locally. After planning, operations is king. And we've already started. To celebrate the launch of our virtual plant, I'd like to invite you to open the first digital factory with me.
I'd be honored. Let's do it.
So amazing and inspiring. That is so cool. And Michael, you've had great experience working with BMW on some of this content, right?
Yeah. We did like the ePolar connector to push the material provisioning, the shelves and the material boxes and this back and forth between our expert application and the holistic digital twin.
Very cool.
Something that's super fascinating is just, most of us probably get in a car almost every day, or at least quite frequently, but you don't really understand the immense, factory size of all the planning, everything that needs to go into this. And anyone that's, built anything by hand or put something together, even if it's some, pre-assembled furniture, you understand how difficult that is when it comes to being in the physical space. So any moments where we can start to, synthesize these operations, these parts and pieces coming together before, they actually hit the physical, becomes a huge opportunity, I think, for a lot of different companies and industries. So it becomes quite fascinating seeing work like that.
Yeah, it seems to BMW has been on the record saying how much it's actually saved them in terms of costs. So yeah, it makes a lot of sense across many industries, but the automotive one is a big one, I guess, because of all the different aspects that go into start to finish of a car. I think previously a lot of those workflows are very siloed from each other, but OpenUSD has seemed to make a pretty significant immediate impact on connecting all those things together, which is pretty amazing. Okay, I think we have some slides to look at. Who will be sharing? Is that Raphael? Will you be sharing?
Yes, I will share my slides.
Okay, great. And while we're waiting for those slides to come up, anyone who's watching, thank you for joining us. Number one. Number two, feel free to post your questions or comments in the chat. I see we've got some nice crowd here already. Nandu, who actually is from the community and does a great weekly OpenUSD study session for those who are interested in exploring. We'll post a link for that in the chat. And then lots of people asking about that robot that Raphael showed off. So Raphael, you got to give people some tips on that. Okay, so let me see. I see your presentation, and here we go.
Now I'm sharing the wrong screen right now.
Okay, I'll remove it, and then we can start again when it starts up in a second.
Yeah.
Well, waiting for that to come up. So obviously, we're just coming off of GTC. Michael, you were part of a great panel there. Mike, you were running around everywhere. So what from GTC would you like to share with the crowd who couldn't make it there that focused on digital twins? I think, Michael, you were part of a great panel there as well, right?
Yeah, it was great to see all these different pieces coming together and the adoption, basically, also the factories, the different domains of the factories, they see they can collaborate with OpenUSD and bring every different domain into this holistic digital twin. And I think, yeah, it's just at the starting point of this movement, I'd say. Yeah. So that was great to see, and the integration of the whole AI stack with generative AI and LLMs, and so this is really coming everything together, and then I think it's really huge.
I think I actually have a really nice clip. I believe Stephanie from our team was moderating a panel, and we can watch the beginning of this. I think it'll give people some good insight.
So, from your perspective, how has USD kind of helped you innovate and helped you solve problems in your industry that you have not been able to do before, or approaching in different ways?
Yeah, it's basically the common language to bring all these different factory domains into one big digital twin. So, and this is enabling everything basically. We come from these data silos everywhere, and we are now able to integrate everything, and that's great. I'm Mike Wagner, CEO and co-founder of SyncTwin, and also I'm an Omniverse ambassador. Our mission is to unlock the industrial metaverse for small and medium-sized enterprises by leveraging OpenUSD and the Omniverse ecosystem. And my journey with SyncTwin began over 3 years ago as a co-founder of Epolog. We're doing software for the automotive industry, production logistics. And that laid basically the groundwork for what SyncTwin has.
That was a nice session.
We're going to go ahead and post a link for that full video. It's a really nice 5-minute highlight video, but I wanted to at least play the beginning because I think that really sets the stage in motion. So Emilio maybe can post that link in a few minutes. I think that was just a post you did on LinkedIn the other day, Michael. So really great content. Okay, and let me see. And I think I see your presentation now, Raphael. So let's open this up. Oh, yeah, there you go.
I made it.
Nice. Hey, Edmar, before I jump into the slides, I'd also like to add, I think, for me, one of the highlights of GTC was just getting to meet so many people that we've worked with over the years in person for the first time. And one of those was my hero, and he's here, Michael Wagner. Have learned so much from the guy and just been such a fan of the contributions he's made to the community, and then to get to meet him in person, I almost had to ask for an autograph, but I thought that would have been weird. So
no, it was great to meet you guys all. It was really a pleasure. Yeah, it was.
That's great. And along those lines, I think the next big event we'll be sharing some more news on very shortly is SIGGRAPH, which I know a lot of people from video will be there and around the world presenting the great research that always comes as part of SIGGRAPH.
Don't forget Computex. Don't forget Computex.
Yeah, exactly. So we're going to be talking more about that in the upcoming weeks. But Raphael, it looks like you've got, wow, that's a big number there, 50 trillion.
Yeah, that's a lot. So, Mike, if you want to, I can share my screen and you can do the voiceover. And
let's just kind of just roundtable on them. So, I think the big thing, about all this stuff and kind of the journey we've been on with the Omniverse developer platform is really trying to help companies like Michael Wagner's with SyncTwin build tools and software capabilities and digital twin capabilities that really enable so many of these different industries to move into a modern era of digitalization. For as advanced as you might think some of these companies that make planes and cars and everything are, when you go and walk through their shops, it's sometimes surprising how much of the stuff is still done by paper and whiteboards, and they all realize that they've got to digitize and they've got to really modernize the way they're doing things, especially with shuffling supply chains and some of the things around labor shortages and volatility in supply chains. There's really a big opportunity for companies to build new factories, to build new facilities as they retool their processes. It gives them a big opportunity to add automation. And so what we see is companies we're working with like BMW, not only are they building new factories, they're adding new processes and new ways to do things. And those things all require having some digital or having a purely digital environment to do that in. So that's kind of the backdrop of all this work, is we really think it's super important, not only for the monetary aspects, but also to help these industries run leaner and cleaner as well. Anything else on kind of the setting the stage? What's the panel to add?
Maybe just some comment, because whenever we talk about the digital twin or most of the examples we share is focused on automotive, but you see here we only cover or try to cover other industries like digital twins in a factory. Wherever you produce something, it does not mean it's only cars. We only will show a demo or a video later on, a customer of us producing some laptop devices, tablets, mobile phones, and others. So BMW was our first big example. It all started with, but it does not mean that that's just happened in the automotive industry. You can have a digital twin in all the other industries as well. So it's not limited to a single industry. The colors and the bits and pieces are a bit different, but digital twins can live everywhere. So
that's a great point. Retail, there's a lot of growth in semiconductor and battery manufacturing. Doesn't even have to be a factory, right? It could be a grocery store or a warehouse, or the product itself, right? And so with this concept of digital twins, this is really the means by which this digitalization becomes a reality. And there's a bunch of things that go into it, but at the base level, it's really about communication, right? It's about helping humans communicate with each other better, to make decisions, but also starting to bring AI and robotics and machine learning into the loop so that the humans can make better decisions. They can be relieved of making some of the mundane and dangerous tasks and decisions that they have to make, but also things like facility designs and operations as well. So there's a bunch of ways that digital twins can come into life, but really, if you think about it at the fundamental aspect, it's having something to look at and make decisions on that isn't a blueprint or a piece of paper or some abstract something on a whiteboard. So
let me ask you one really quick too, because this probably ties into this what you're about to talk about. But the term interoperability seems to come up pretty regularly when you're discussing OpenUSD, and it looks like the first thing you're mentioning here in this slide, open standards, really is what gives that the power with OpenUSD, right?
It's so spot on, right? Is you think about if I go back to the kind of oversimplification of what is a digital twin, it's about communication. What is communication is really about the language that you speak, and being able to speak the same language and use the same terms and exchange ideas and concepts freely. It's hard to have a conversation with someone that speaks a different language, especially a meaningful conversation where you're trying to make some decisions. And so we found that a lot of the companies that are embracing USD have similar problems, and they have similar things that they're trying to do with just communication. And they found that USD is a good mechanism for them to connect these different data sources or these different languages that they've used over many, many years and have become entrenched in their processes. So they can't really get rid of those data types, but they just want to be able to extract and insert different levels of information into them.
Yeah, OpenUSD has just been tremendously helpful for that, breaking down all of those walls, especially when it comes to interoperability, because certain software is good for their specified use case. Maybe it's something extremely technical, so they're not focusing on the visuals of it. Maybe it's something very visual, so they're not focusing on the technical aspects of it or very fine details. But with so many companies embracing OpenUSD, it really allows for all of those workflows to come together and for different platforms to be able to, produce and put forward their value and allow so many different people to collaborate, which has been, it's been a blocker since software's come out. So it's a fascinating opportunity for so many companies, but also the users of these software in terms of how they can collaborate with designers and engineers and the factory planners and whoever else they're, and customers as they're working through their workflows.
That's a great point. I just put a link in the chat so everybody can check it out later for the Alliance for OpenUSD. If you want to take a look at some of the companies that are part of the founding members, helping champion and assisting other companies on adopting OpenUSD, check out that link. If you want to get more involved as a company, lots of opportunities there. There's a great Alliance for OpenUSD forum. But more news on that in a future live stream. I think we're planning to actually have a live stream dedicated to that topic later on. Okay, that's fantastic. All right, so what else do we have?
May I add, it's not only the graphical properties, as you see a lot, but also other properties like physical or any metadata, which is interesting for other parties involved. So this is a great aspect about OpenUSD, that you can put every kind of information into this, and they
also a brilliant point. Aaron Luke on our team has put together an amazing live stream series or a video series on YouTube about the powers of OpenUSD. We'll post a link to that in the chat also if people want to dive into that. There's also a great DLI course on OpenUSD. So lots of great resources out there. If anyone needs any help, you want to talk to more people, you can always come to our Discord server, which is discord.gg/NVIDIA Omniverse. Okay.
Yeah, so it's a great discussion there around the importance of open formats and the communication and what OpenUSD enables. The other big piece of the key technology is really around computer vision and generative AI, right? Is allowing these mechanical systems to have the ability to sense and perceive where they are in space and what is going on around them. If a human's walking in their path, if something has fallen in their way, to be able to avoid accidents, to be able to move more efficiently, and then also to train these environments, you got to create many permutations of situations that robot or that equipment might encounter. It's really challenging to do that in the physical world, but that's a great application for digital twins where you can use synthetic data generation and these environments to create all those different scenarios. What if the lights go out? What if the power goes out? What if the box falls over? What if a human does something weird and turns around and walks towards the robot? All of those things can be simulated to create these training grounds for AI to really learn how to operate the digital twin, or how to operate the facility itself. And then the third piece is really the horsepower to run all this. Right, is anybody that's been in this space for quite a while knows that starting to build up a complex system is really taxing on even a local workstation, a local data center, whatever it is. And that's where we're really fortunate to be in the position of having access to so much amazing high power compute and accelerated computing as part of this platform. And really the underpinnings that makes it all work is you can have million square foot facilities. You can have big container ships with 1.5 million discrete parts in there. Enjoy the benefits of experiencing that entire system in its entirety, not just a little piece or a bit at a time.
That's a great point. And we actually have a really good question here that I'm going to put on the screen for a second, but maybe we can dive into this a little bit later. This is from John. My company, Semiconductor Tools, has been considering digital twins for both physical model and data. Would anybody be willing to share their experience workflow for integrating internal data sources? So this might line up very nicely with the demo we're going to show off in a few minutes, so we can discuss it when we do the show and tell. But John, it's a great question, and you are watching the perfect live stream for that. But yeah, keep the questions and comments coming, and we'll try to get through them all by the end of the show.
I think just to touch on John's question, John, answering that is a multi-day, multi-week endeavor, but in its entirety, and to really touch on all the nuance of your specific data systems. But I think the thing I would comment is you're asking the right question, and it really is about how do you add some unification across your different data sources, and a lot of that is dependent on your organization developing that kind of architecture for the data, or that kind of taxonomy. But also, I think we touched on this in the last slide a lot, is having these open standards like USD that allows you to flexibly connect other data sources. You don't necessarily have to convert them, but you can connect them, and USDs kind of becomes like a connective tissue for that. So I think we touched on USD quite a bit in the previous one, so maybe unless somebody wants to add something else here, we'll just zip ahead. I think this is a great point. The computer vision stuff also touched on that a little bit, is really giving these mechanical systems the ability to see and reason with the world around them. Then I think we're probably close. Let's see. Virtual and physical system. Yeah, with AI. Okay, and so these are just kind of clicks that go a little bit deeper into those last slides that we touched on. But I think that maybe I'll use this to close out the slides and really bring it back to what we talked about at the beginning, which is, what is a digital twin? It's the combination of a physical and a virtual system. And those virtual systems are used to help humans be more efficient, to help machinery run more efficiently, to help solve problems, ultimately make decisions, and to create training grounds for AI to further augment all of those things. And so, yeah, maybe this is a great slide to close on. So I don't know if Sebastian or Raphael, do you want to take us home and talk about this one?
It's kind of a super simplified slide, because whenever you present something, okay, keep it simple and crisp. So when we talk about digital twins, you already mentioned it. We also, and we as NVIDIA, we always want to talk about accelerated computing. So it depends on how you define a digital twin, but as Mike started at the beginning, we can talk about hours and days about a digital twin. But these three parts of it, this is how we see it on a high level. When we talk about a digital twin in Omniverse, AI is included, is an essential part of it, because that's the way to go. And if you guys watched GTC a couple of weeks ago, you saw a lot of robotics announcements. So these two components are from our perspective, super essential when we talk about an Omniverse digital twin. We also talk about AI, and we also talk about robotic system. So it's glued together, and the three components are DGX for AI, for accelerated computing, is Omniverse in the cloud, to run your digital twin, to build up your digital twin, and to connect it with robotic systems powered by AGX. So to bring a bit of a hardware discussion into this live stream, you can see this as our 10,000-foot definition of a digital twin, and it's glued together, these three pieces.
That's so perfect, Raphael. I would just add, I would say our CEO Jensen did a fantastic job kind of using this slide as the backdrop for a lot of the GTC content that he presented in his keynote. I'm sure everybody here has watched it, but if you haven't, it's a great chance to plug that to kind of hear some of the more elaboration on the concepts here.
That's a great point. We'll put a link to the keynote in the chat so everybody can watch that. It's a really amazing watch. And then we've also been posting links throughout the live stream as we've been talking about stuff. So if you've missed anything, open up the chat window and you'll be able to see some great links that we've been sharing along the way, including for OpenUSD resources. Okay, great. All right, so I think that presentation is done. So let me see, I'm going to close that. All right, so we have a couple of other videos here. Do one of these make sense to play right now, or do we want to dive into a real-time demo?
I would maybe recommend to run the Pegatron one.
You know, I was hoping you would say that, because this video is pretty awesome. All right, everybody, definitely get your popcorn. Do you want to kind of tee this up a little bit, Raphael?
I spoke about don't focus that much on automotive because it all started on automotive. But Pegatron is how compared to what we saw, how BMW did it, how a different industry build up their digital twin and what's possible. So you can compare. This is how a digital twin in automotive looks like, and this is a digital twin how it looks like a bit different in a different industry. And so it makes perfect sense. And it's just this video is just gold. So enjoy it. It's really good.
I agree. Okay, everybody, buckle up. We'll see you in 2 minutes.
The $45 trillion global manufacturing industry is comprised of 10 million factories operating 24/7. Enterprises are racing to become software-defined to ensure they can produce high-quality products as quickly and cost-efficiently as possible. Let's see how electronics manufacturer Pegatron uses NVIDIA AI and Omniverse to digitalize their factories. In Omniverse, they start by building a digital twin of their factory, unifying disparate 3D and CAD datasets to provide a real-time view of their complex factory data to their planners and suppliers. In the cloud-native digital twin, planners can then optimize layout virtually before deploying changes to the real factory. The digital twin is also used as a training ground and data factory for Pegatron's perception AIs. They use NVIDIA Isaac Sim, built on Omniverse, to simulate and optimize their fleet of mobile robots, which help move materials throughout the facility, as well as the pick-and-place robotic arms that assist on production lines. In the fully operational factory, Pegatron deploys automated optical inspection, or AOI points, along their production lines, which reduces cost and increases line throughput. NVIDIA Metropolis enables Pegatron to quickly develop and deploy cloud-native, highly accurate AOI workflows across their production lines. Omniverse Replicator generates synthetic datasets of PCBA defects, which are too complex and costly to capture in the real world, like scratches and missing or misaligned components. Pegatron then combines the synthetic data with NVIDIA pre-trained models, NVIDIA Tau for training, adaptation, and optimization, and NVIDIA DeepStream for real-time inference, resulting in AOI performance that is 99.8% accurate with a 4 times improvement in throughput. With software-defined factories built on NVIDIA AI and Omniverse, manufacturers can super accelerate factory bring-up and minimize change orders, continuously optimize operations, maximize production line throughput, all while reducing costs.
That is awesome. That's great. It actually lines up perfectly because we had a question earlier in the chat about what industries is Omniverse kind of made for. And I think it's important for everyone watching who's just learning about Omni for the first time that it's a development platform. So basically, nearly anything is possible, no matter what industry or vertical you're working on. And we've obviously shown some great use cases, including automotive, that benefits pretty significantly because of their general workflow. But there are many industries like the one you just saw that are leveraging the platform for their digital twins.
Yeah, I think what also one of the things that it also unlocks is once you bring all of those physical items into the digital world, then you can run all of these simulations and operations that you previously couldn't, or would be really difficult or kind of time consuming. So in a world where you can do one thing, in a physical world where you can do one thing over the course of an hour, you can now parallelize that, and you can do 1,000 of the same operations, exponentially increase your training data or information, and then be able to act on that, or build out synthetic data, however that may happen. So it's a pretty fascinating paradigm.
And then imagine if you have an up and running digital twin supported with AI, and think about some use cases. This is a use case we were able to do 5-6 times a day, and with AI you can do it multiple times, or you can think about some completely new use cases using AI in a digital twin in a factory. So and then scale it up on your data center, on the cloud, wherever you want it. So it starts to explode when you think about use cases and potential. So that's really great. But I guess I'm looking. We have a couple of minutes left, so maybe we should jump to the live demo now, because I guess everybody's waiting for it.
Let's do it. Okay, so Michael, I'm going to be sharing your screen, correct?
Yeah.
Okay, here we go.
Yeah, I've brought a little demo from us. You see here a factory environment, right? Different elements like material buffers, like resources, like a robot cell in the background. And you, John, you have asked about the how do we get there, right? And how do we integrate our internal sources? That's exactly the right question, because a lot of smaller enterprises, they have like Excel and PowerPoint as their data source, right? And so what you see here has been generated only using PowerPoint and Excel, with also here some transportation networks, because it's using USD and the whole Omniverse ecosystem.
Wait, so hold on, Michael. We have to point that out again, because what you just said is kind of crazy. So what everybody is, correct me if I'm wrong, but did you just say everything you're watching right now is basically put in the scene by PowerPoint and Microsoft Excel?
Exactly. I just opened the PowerPoint, and then this is basically what we put in. We just have a rough a plan, which is like we have from architect, maybe a 2D layout, and we just have put in some rough areas. There is a dock station, there is some storage, and we've added some detailed slides with describing our environment even more, and we basically talked to the AI assistant, to SyncTwin, to our system, by writing text into PowerPoint. These are like commands, but also we can use like natural language. And I say, okay, this is basically a material buffer, right? With 6 rows. And we're using a stack of 4 containers, right? And here is a forklift, and we also painted in some transportation network, which and everything you see is converted into OpenUSD components. So the transportation network, it can then be used with a QOP, for example, with the optimization component, right? And how does it work? Basically, I'm allowed to get a little technical, so this is basically what we do, and this is connects to your question: how do we connect these sources, the different sources which are here, the most basic sources, which is excellent PowerPoint, but you can also have like databases or your expert tools like Epolog, for example, or like all these different data silos you can bring in, and as soon as you have like this OpenUSD connector and you transform your data into domain elements with OpenUSD, like containers, with activities, vehicles, orders, and we combine this into a simulation scenario. And also, as Raphael said, we can do thousands of scenarios, right? By using this kind of pipeline approach, and also mix in a live IoT layer as well, as this is the reality coming in, right? And so yeah, that's basically what we do. That was PowerPoint. Same for Excel. So for example, I've got my my Excel data here describing some parts and some containers, and I just add a little extra mapping information. So basically, we can convert this into OpenUSD components, and this is exactly what happens here. For example, for the containers, we've now converted this information into meta information in the USD, and now we can use templates in our Omniverse environment and convert this to elements like this. As you see, they're real looking, and that's a great thing about the Omniverse as well. You've got lots of different assets already in. You've got also asset providers. You can buy assets, and these are not only the graphical elements, but also they contain basically the metadata, and that's the real the secret sauce, I'd say, in all that. Here you see it has a container number. It has like some schema as well, which defines this element so if an AI looks at it, it can instantly see, oh, it's a material container, for example, right? And so we've got another Excel combining these containers into loading units, so into the next like component which makes up different bundles. You see here, I've got a stack of 4, I've got a single, I've got a 9th stack, and if you use that and load it in, so also what you see here is USD data, right? And now we've combined these single containers into these bundles, right? And this is what we use in our PowerPoint again. So we say, okay, let's make a buffer of these stack of 4, and as you see, this is one stack of 4, for example, and by adding also an LLM, a large language model agent, basically we can talk to the application and say, show me the simulation, for example. So I hope it works. Let's see. So see, it said, it understood it, and now it like controls the service of Syncpin and says, okay, load in the simulation, and that's what it just does right now. Takes a little time to display. We've got the. There we go. See, so it also loaded, and you see here the 4 stack of containers we used here, and also we can then ask the assistant. So this is a great possibility to add assistants like AI enabled assistants which go into the scene and examine it. And I say how many containers are in the scene. So and has collected the information just by looking into the USD structure and extracting basically the different elements. And this is, I think, a really great thing of combining the different elements of the factory domain and all integrating the different players, the human parties, as well as some AI assistants. And so this is basically how we use OpenUSD and the different services which can reside anywhere in the cloud, right? We've got our visualization, and everything speaks together with OpenUSD. And I've brought a little another example as well, how we can then use this with a physical simulation. Here, for example, I'm taking this container we just created out of Excel, right? And also I've created like with generative AI, I said, give me a rubber duck with a cowboy hat, right? So this is the model I just downloaded with OpenUSD as well, right? And I say, okay, how many of these rubber ducks with cowboy hats fit into this container? So I can use the Omniverse physics engine. It's a physics-based environment, right? And actually see how many can I put into this container without like dropping some elements. And here, for example, an AI generative AI special favorite German food is Spätzle. That's kind of pasta. And I said, give me a Spätzle burger, you know. So I created like this.
That's typical Swabian, Michael. That's
Swabian,
not
yeah.
German. That's Swabian.
Yeah. So kind of
That's incredible.
And so you can like do all this by bringing all these different elements together. I think you've got a really big potential to create your digital twin.
The one thing I love this demo so much is because it starts with excellent PowerPoint.
Yeah.
And whenever we talk to customers or partners and we ask them, or when they start to try to build digital twin, we ask for what data do you have and how they do it, or how they did it before. Yeah, we did it in PowerPoint, or we did it in Excel. So it's still there, and it will take some time to get rid of it. But that's a perfect example how you can bring together these two worlds from a PowerPoint or Excel spreadsheet into a physics-based developer platform to do some great stuff Michael just shared. So that's an awesome example.
Yeah, I mean, with so we have hundreds of people watching live right now. Lots of great comments. People are blown away by what they're seeing, Michael. So thank you so much for sharing. It really is incredible. But you know, one of my big takeaways whenever I see stuff like this is that how accessible this seems to be for developers globally, right? Where it doesn't seem like anything nearly as complicated as this would have been possible even just a few years ago. And that just really is mind-blowing and really excites me for the future of what developers are going to be doing with this this technology. Really great questions here. We actually had a good question that would be good for anyone on this panel, but I see Andre just asked this. Many thanks for this session. It's great. You probably already talked about this, but I'd like to ask anyway. How are the materials or textures created in this pipeline?
Differently, you can, like here we've got a generative AI approach. You can also do like scanning, right? There are basic tools like your iPhone or something, right? or use a Nevis, for example, laser scan with textures. It depends how on the use case. You guys.
So for anyone, and for anyone wondering, so SyncTwin, I put the link in the chat so you can look at Michael's company application there, which enables digital twins pretty much at mass. So I encourage everyone to take a look at that. Follow him on LinkedIn, of course, because he posts a lot of great information on there. So thank you for that. Michael, are you able to share basically how? So SyncTwin is relatively new. Followed up from Epolog. What can you share about the developers that are currently leveraging SyncTwin today, or what are you seeing, or what does the future hold for developers? And what types of developers are you seeing?
You can. Most basic thing is to start with Python developing, right? You can also now use the cloud services, cloud APIs. One thing is to get your head around this whole USD approach. Basically, how do you organize your data and your data pipelines, basically, and your whole digital twin structure, right? It's as soon as you think of this holistic approach, you are forced to also do the connections in your brain, right? Bringing all these different elements together. And as you said, the tutorial of Aaron Luke is just great. This I highly recommend it. Yeah, to get
Michael.
into it.
And as a follow-up to that, how many people do you have? How many developers on your team are actually working on this? How large is your team?
Just two basically. So it's
team of two.
Also, and we say it's basically well, my other company is like 46, but we also want to be like as much as AI augmented as possible. So we use basically all these AI agents ourselves to code and to build things. So I think this is kind of also the new way of working in my.
That is absolutely amazing, pretty mind-blowing. So thank you for also sharing that. We only have another minute or so to go. So I'd like to open it up for any final questions or comments from the crowd. Let me see if I missed anything. Renan is asking, wow, there's so many questions about the back end. So that'll probably have to be another live stream. Or actually, I will say Michael is actually very active on the Omniverse community Discord server. So if you want to chat with Michael there, we have a channel specifically for live streams. So you can go to live streams channel and ping Michael there or ask a question. I'll tag him. Again, that address is discord.gg/NVIDIA Omniverse. It's a great place to go to talk to other users of Omniverse. Okay, somebody's asking, is there a way to switch the PhysX engine with another or add additional engines for particular tasks? So I don't know if anyone from the NVIDIA team wants to tackle this. In general, it's a development platform, so people can pick things apart and add.
Yeah. Sorry, Edmar. I was going to say, that should be possible. I mean, it depends on what exactly you're trying to do, but that is the idea, is that different engines and different capabilities can be pulled together to kind of remix and build your own.
That's great. Okay, thank you. And then we have another question from Perceptino. Can the client-side application using the Omniverse application be a different standalone app?
Definitely,
yeah.
Yeah, that's the whole idea. Yeah.
Yeah. And as we announced at GTC, which should be incredibly exciting for all the developers out there. If you missed the announcement, but we're making the technology, the platform available through API calls, and there's going to be a lot more accessibility to all these functionalities and features through API. So we're going to have more news on that in the coming months. That is super exciting. And really just opens things up and makes things a lot more possible for many more people. So we're very excited about that and excited to share that as it comes along. Okay, cool. I think those were the main questions and comments I saw. I think we covered a lot of these in different areas. If you have any questions that we missed, feel free to hop on over to the live stream channel in Discord again, and feel free to ask there, and I'll tag the right folks in. Let me ask the panelists who are here, any closing thoughts or remarks, or what would you like to leave people with today? It looks like we definitely have over a couple hundred people watching at the moment.
1 hour is not enough. So.
Yeah, that's true.
Yeah. No, it was great. I mean, great to cover all these things, different type of how to work in a digital twin, different examples from different industries, all these modules. Michael covered a lot when we talk about AI, how it can look like, maybe give some bits and pieces how the future can look like to run those things with just two guys. And the example is just great to see. So
that's yeah, I couldn't have said it better. And regarding needing more time. So I wanted to share everybody who's watching. This is actually part of a new live stream format that we're exploring, and we love your feedback on it. So basically how it's going to work is that every month we're going to feature a different topic. And this month is obviously focused on digital twins as we're kicking it off today. And then each week we'll cover a different component. Like the first week today is an introduction and overview, where we kind of go over things just like we did from the top down. The second week of the month, we're going to go into a partner spotlight. So we're actually going to have someone live stream who's actually leveraging the topic in their own industry or workflow. Week number 3 will be a Learn With Me session where we actually kind of dive in and get hands-on experience through walkthroughs and mini tutorials and reference different architectures. And then finally, we'll have, to finish off the month, will be a community spotlight. So week 4 we'll invite people from the community who are coming and leveraging the technology, and we'll get to show off their projects and inspire others. We would love your thoughts on this kind of format. I'll put a link in the chat for a short poll you can do. And if there's something that you'd like to see, a specific topic you'd like to see covered, I absolutely would love for you to engage with us there. Let me see if I can pull it up really quick. Amelia, I might ask you actually, because I can't have too many windows open right now. Amelia's going to post in the link to the chat so you can give us your feedback on the proposed format, and then give us any topics that you would love to see covered. But with that, I will say thank you so much. We have a super exciting live stream next week with SoftServe and Continental. That's going to be absolutely fantastic. Check out the event calendar for more details. We'll post a link in the chat as well. Michael, I cannot thank you enough for everything you've shown today. Really just mind-blowing, very impressive all around. You're always so giving to the community. You're just an amazing Omniverse ambassador. We're so honored to have you as part of our stream. So thank you for coming.
Yeah, my pleasure. Thanks. It's very nice to be here again. Yeah.
Raphael and Sebastian, I think Sebastian had to leave for another meeting, but Raphael, thank you so much for being here and bringing your boss along. It was very nice. Mike, thank you both for coming so much. Really, really great. And most importantly, everyone out there, thank you for watching. If this has been a helpful live stream for you, if you learned something and you're excited for the next ones, I urge you to like and subscribe to our channel so you get notified of all these live streams in real time. Liking the content will also really help other people discover. And obviously, the more people that are leveraging OpenUSD, the greater it is for everybody. It's a huge ecosystem growing by the week. And that's all because of people like you out there working with it, Mr. Michael Wagner. So with that being said, I will see you on Discord and on the forums. Until then, have a great rest of the week, everybody.
Thanks, everyone.
Yeah, you too. Thank you.
Bye.
Bye.